the state of the system. In fact, the state of the system can also be called state variables. We should describe the system in order to make some useful calculations by specifying the system quantitatively, either in terms of pressure or volume or temperature or all. So pressure, volume, temperatures. These pressure, volume, temperatures are called state variables because they depend on initial state and final state of the system. Now we can define the state variables or state function. So what are state functions or what are state variables? When the question is asked like this, what are state variables or what are state functions, means you can cite the examples like pressure, volume, temperature, etc. But when you are asked to define what state function is, the state function or the state variable is defined as when the system is interpreted based on the initial and the final state, then it can be called state of the system. So what do you mean by state variable? It depends on the initial state and final state only. Similarly, we have path function also. What is path function? Path function is the one which depends on the path of the system and not on the initial state and final state. Do you understand? So what is state function? It depends on initial state and final state. What is path function? It depends on path and not depend on yes. Okay. Usually these state functions are called thermodynamic properties and they should always be represented by upper cases only. For example, pressure should be represented as capital P, that is uppercase P. Similarly, volume, that is also a state variable. So it is represented as capital V. Pressure, volume, temperature. So what is temperature? It is the degree of hotness or coldness. So temperature, T represents temperature, capital T. Similarly, we have energy. It's called internal energy. Internal energy is represented by U or sometimes E also, capital E. So U means internal energy. Actually, this internal energy is a function of state. Is a state function. It depends on the initial state and final state only. And it is the function of temperature and volume of the system. Okay. But there is another term called enthalpy that is represented as H, capital H. So this capital H, that is enthalpy, is also called heat content. Are you able to follow? So it is a function of temperature and pressure. Okay. So E is the function of temperature and volume, whereas H is the function of temperature and pressure. So you can simply represent this as usually these internal energy, enthalpy, these are all represented by the changes only. Okay, it would be very difficult to identify a single, the internal energy at one state or at another state. So always we represent this by differences, change. So it's called change in internal energy, delta U. Okay, take down. So delta U is a function of, you can put delta U is equal to F of small f, F of, open the bracket, T comma V. close the bracket. And similarly, f small f is, delta U is equal to f small f of, that is open the bracket, f open the bracket, T comma capital T. I said already, all thermodynamic properties should be represented by capital letters. Okay, this f represents the function, so T and V. Okay, right. And similarly, enthalpy is nothing but delta H, that is change in enthalpy. Capital H is a function, is equal to f of capital T and P. Are you able to follow now? Okay, this is a function of temperature and volume. That one is a function of temperature and pressure. Okay, so it means that is the change in the temperature at constant volume, that is internal energy. When it is taking place at constant pressure, when heat change is accompanied at constant pressure, it is called enthalpy. Are you able to follow now? Right. Then, and there is a relationship between this delta U and U2, U1. So U2 is nothing but the final internal energy. U1 is the initial internal energy, that is at one state. At initial state you can mention. So U1 represents the internal energy at initial state. U2 represents the initial internal energy at final state. So delta U means U2 minus U1, that is final minus initial. You can put UF minus UI also, otherwise U2 minus U1. Is it clear? Or some people, they represent by UB also, UB minus UA. So these are all different representations. Similarly, how can you represent the delta H? Delta H is equal to H2 minus H1. So that is the change in enthalpy. That is final enthalpy minus initial enthalpy. Always remember capital letter only. Capital letter. Okay, capital letter U. So there are some meanings for this. Okay, right. So all thermodynamic properties, please note down, please make it as a note. All thermodynamic properties should be represented by upper cases only by convention. Okay.